In this video, we're going to focus specifically on cardinality. This is section 1.1, or in section 1.1 of your textbook. What is cardinality? Cardinality is the cardinality of a set is a number of elements contained in the set. So for example, let's say we have set S, and it has cow, duck, pig, and horse. The cardinality of that set is going to be the total number of elements in the set. The elements are cow, duck, pig, and horse. How many elements is that? That is a total of 4 elements. So the cardinality of S is 4. If we want to denote this using mathematical symbols, we use n of set S. So n stands for number, and the set inside the parentheses, that's the set that is given. So suppose we have G. G is the set that contains the elements of M, C, A, N, Y. If I want to find the cardinality of set G, I would write n of G. By definition, is the number of elements in the set. 1, 2, 3, 4, 5. So the cardinality of set G is 5. That's all cardinality is. So let's determine cardinality of certain sets. Let's look at set number 1. Do you remember what that symbol is? That's an empty set. The empty set by definition is the set that has no elements. So the cardinality of the empty set is 0 by default. The set of states in the United States. If we count only the ones that are in statehood, the cardinality of that set would be 50. K is a little trickier. If we want to find the cardinality of K, we need to know how many elements are in set K. If you recall, the ellipse shows a continuation of a pattern, but we're not writing all the elements that are there. This is list form without listing everything explicitly, but we can imply what's in there. So it looks like we have the numbers between 1, the counting numbers from 1 to 25. So how many numbers is that? 1, 2, 3, 4, 5, 6, all the way up to 25. So there are 25 elements in set K. What about T? The set T has the elements of pepperoni, black olives, sausage, mushrooms, green pepper, cheese, and pineapple. So if I want to find the cardinality of T, I simply count the number of elements. The elements are the pizza toppings. 1, 2, 3, 4, 5, 6, 7. The cardinality of T is 7. Now let's talk about intersection and union. An intersection, just like you would think of any other type of intersection, is just where two sets intersect. In this case, by definition, it's simply the elements that are in both sets. As you can see here, there is a mathematical symbol for intersection, which is an upside down U. Union, on the other hand, is the collection of all the elements in all the sets. Here we have the up symbol, an upper U for union. So let's practice. Let's suppose we have set S, which contains the elements 1, 2, 3, 4, 5, 6, and the set V, which contains 0, 2, 4, 6, 8, 10. So here I want to find the intersection of S and V. So here I want the intersection. So that means I want to find all the elements that are in both sets. So what do both sets have in common? They both have 2, they both have 4, they both have 6. And that's simply the intersection of those sets. Now let's talk about the union. The union is all the elements in all the sets, which means I need every single element present, which means I need 1, 2, 3, 4, 5, 6, 8, and 10. You'll notice that I only wrote 2, 4, and 6 once. I don't need to repeat the elements. I can write them as distinct elements, but this would be considered the union. It's all the elements in all the sets. So now let's find cardinality of intersections and unions. Let's suppose we have S is red, blue, green, yellow, opal, and the set F is yellow, green, purple, white, black. Let's suppose we want to find the intersection of S and F. What elements do they have in common? They both share yellow and green. We can highlight that. Let's not use that. Let's use this one. So we both have yellow and green. So the intersection is going to have yellow and green. Could I write green and then yellow? Yes. The order of the elements is not set. It is the elements themselves that are set. Now let's talk about the cardinality of that intersection. Well, how many elements are in that set? 2. So the cardinality is 2. Let's look at the union now. Remember that this is all the elements. So I'm going to take all the elements in S and all the elements in F. If there is some repetition, I only need to write the element once. Remember that the order of it does not matter when it comes to set writing. So we have red, blue, green, yellow, opal, purple, white, and black. Oops. There we go. Oop. Okay. When the cardinality of the intersection we look at, again, we just look at how many elements are in the set. 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality of the union of S and F is 8. We'll see in the future when we talk about Venn diagrams that we can create 2 or 3 sets and look at these intersections and unions and the cardinalities of all those.